Hello, and thank you for joining me for the Toolkit Week 11 video. Number one, so we want a line through the point, -4, -4, with the slope 1/2. So remember, each time the y changes 1, the x is going to change 2. Okay, change in y is 1, change in x is 2. So we start with the slope-intercept form of the equation, the generic form, and plug in what we have. So we have x and y. Now this right here is not the y-intercept. It is a random y value that only happens when x equals -4. If x was 0, then we would have the y-intercept. So this means I can plug in any ordered pair that go together and the slope and then solve for b. So let's plug in -4 is equal to 1/2 -4/1 plus b. Cancel or just take half of -4 is -2. Add 2 to both sides. B is equal to -2. So I have y equals 1/2 x minus 2. Okay, now to complete our understanding, let's see what this means in terms of making a table. Change in y is 1 every time the change in x is 2. So when the change in x is 2, the change in y, so we're going to ignore that. The y goes up 1 every time the x goes up 2. So -4 up 1 is -3. So every time the x goes up 2, the y goes up 1. So according to our table, the y-intercept is the coordinate where x equals 0. According to our table, the y-intercept is -2, which is what I got when I plugged into the equation. Number 2. Now, first of all, let's do a little review. Notice the difference between these two. Base to the power, base to the power. Add 1 base to the power to the power. We call these superpowers. We have x to the 12th. You multiply 1 base, 2 powers. Okay, so all of the top has an exponent of 4. Everything in here. Notice these terms are being multiplied. There's no plus signs down here. So 2 has an exponent of 4. X to the 4th has an exponent of 4. And y to the -3rd has the exponent of 4. So 2 to the 4th is 16. X has superpowers. We multiply. Y has superpowers. We multiply. And on the bottom, 2 times 2 is 4. X to the -2. On the bottom, 2 times 2 is 4. Base to the power, base to the power. Add those exponents. So the first thing we're going to do is divide your coefficients. For those two x's, 16 on top, 2 on the bottom, subtract. Now, the y has a negative exponent. We're going to cross the line, change the sign. So it becomes y to the +12th on the bottom. Number 3. Okay, so first, because there's 2 terms in here, I have 2 terms multiply by itself another two terms, I'm going to have to make a box. Okay, this is not just the -4 has the exponent and the 7i has an exponent. Because of that plus sign, step 1 is to split. Step 2 is to make a box and multiply. -4 times -4 is 16. -28i, -28i, and 49i squared. Okay, next step, combine like terms. We have 16, -28i, and -28i is -56i plus 49i squared. Now, you can leave I in your expression. You cannot leave I squared. So if we have I squared, we have to replace it with -1. So I squared is -1. So we have 16 minus 49 minus 56i, and 16 minus 49 is -33 minus 56i. Number 4, make a box. Fill in the box. Now, i's you can leave. I squared, you must replace. You must simplify. So this is 3 times -1, which is -3. So combining like terms, 24 minus 3 is 21. -8i plus -9i is -17i. The i's you can leave, I squared must be replaced. Number 5, factor completely over the complex numbers. Now, in the past, we've seen this and we have said cannot be factored. We know that we have the difference of two squares when there's a minus in there, but not when there's a plus. So if there's a minus in there, we take the square root of the first term. So that's 5m and 5m, 1 plus 1 minus. We take the square root of the 9, okay, leaving that minus there. That minus is just there. Square root of 9 is 3 and 3. Now, if we made a box and multiplied that, it would get us back to 25m squared minus 9. So we're going to use that same concept. So this is 25m squared minus, so we could use the difference of two squares shortcut, -9, because minus and negative is plus. Okay, so this is how we're going to factor it. We're going to take 25m squared and split it into 5m and 5m, 1 plus 1, 1 minus, because that's the way difference of two squares works. Now, I need to take the square root of -9, which is the square root of -1 times square root of 9. Square root of -1 is I. Square root of 9 is 3. 3 plus 3i minus 3i. Now, I don't want to do 9 again. Let's do 49. Okay, so we're going to change this to 4r squared minus -49. 4r squared breaks into 2r and 2r. 1 plus and 1 minus for difference of two squares. The square root of -49 is 7i. So we have plus 7i minus 7i. Notice these are the complex conjugates, Because there's a pair of them and the way they work, when you multiply it out you would get back to the original expression with no i's. Let's see how that looks. 2r plus 7i, 2r minus 7i, which is 4r squared, negative 14 ri, positive 14 ri, and negative 49i squared. Okay, notice our diagonal, one plus and one minus, those cancel each other out. So you would have 4r squared minus 49i squared. You can leave i's. You must replace I squared with negative 1. So this is 49 times negative 1, which gives us 4r squared minus 49 times negative 1 plus 49, which gives us back to our original problem.